Thank you for attending RSA webinar today. My name is Rafał Gawenda and I will be running today's presentation together with my Oski. The topic of this webinar is Revit robot interoperability. You can find information about our new series of robot webinars under these links. Let me remind you about the concept of RSA webinars. We will focus on one of the several topics in order to discuss issues frequently submitted to the support team. We will begin with the general introduction of selected features of the program and develop these subjects further based on the feedback we will receive from you after each of the presentation. Please mind that these webinars are not supposed to be training sessions. The topic of today's webinar is Revit robot interoperability. We will show capabilities of this tool, demonstrate how to use it, and also some hints how to properly create a Revit analytical model or correct it will be given. The topic of next webinar is Advanced Steel Robot Link. Seizing the opportunity, I would like to introduce to you Autodesk Knowledge Network site, where you can find useful articles on the topics covered during this webinar, as well as on many others. Structural analysis link between Revit and robot is available in Autodesk App Store under the name Structural Analysis Toolkit. Direct link to it is displayed at the bottom of this slide. After link installation, it's available either in Revit or in Robot. In Revit, it can be found in Analyze tab, Structural Analysis panel, under Robot Structural Analysis button. In Robot, you can see it in Add-ins and Integration menu. There are two methods of model transfer between products. First, direct integration. Link connects both of these programs installed on one computer to exchange the data. That's why it's required to have both of them installed on one computer. Second, by intermediate file. Additional SMX file is created so the file can be exchanged between users and our computers. Structural analysis link, understanding of the windows. Please select options from the perspective of the program, the program you are working currently. In general, export means send, import updates means update in these windows. So, for example, importing model to Revit is the same action as sending model from robot. Let's look at object transfer between Revit and robot. As robot is much simpler, it contains only analytical elements, and Revit model may contain objects from different disciplines such as architecture, structure, MEP, and so on. So let's look at Revit objects. Revit elements, which can be exported or created during import from robot, also updated from robot, are available as structural elements. But additionally, these elements need to have analytical model enabled. As a default, it is enabled for all of them. There is a list of Revit structural elements in green panel of this picture. They contain analytical representation. See the left side of the blue panel. But there are some items needed for structural or calculation purposes not connected or not represented by any real Revit object. They are listed on the right-hand side of the blue panel, such as loads, load combinations, load cases, analytical nodes, analytical links, it means rigid links in robot nomenclature. Boundary conditions are understood as supports such as point, nodal support, line, area support, which can be applied directly to Revit analytical elements. In Revit, they are available in Analyze tab or during analytical model adjustment, such as analytical nodes and analytical links. Quick look at structural element properties. If the object has analytical representation, Enable Analytical checkbox is marked. Analytical properties can be also displayed in Properties window after selecting analytical representation in this window. See the right-hand side screenshot. Whole analytical model or level or section view or elevation with analytical elements can be displayed either using predefined analytical views in structural template or turning on analytical model categories to be displayed in Visibility Graphics window. On this slide, you can see how objects are transferred between Revit and robot objects. Some of these transfers are unidirectional, some bidirectional. Especially look at the bottom part of this picture. Supports modeled in Revit as physical objects are exported only to robot. Robot supports are subjected to be analytical boundary conditions in Revit. Here we can see the list of bar properties exchanged between programs. They are geometry, section, rotation angle, material, releases, rigid links, and the local coordinate system of bars. And now a list of the wall, slab, or floor properties exchanged between the programs, such as geometry, thickness, material, and local coordinate system. In addition, two remarks. First, slabs, floors with orthotropy are transferred with homogeneous thickness. Video example under the link at the top of this slide. In case of multi-layered slabs or floors in Revit, only structural layer is considered in the link. Case of Revit materials. Structural analytical Revit objects should have materials with physical assets assigned for calculation purposes. Sections. Section shapes can be transferred between robot and Revit in three ways. First, by type mapping. Standard sections such as steel database sections, Revit standard steel sections, typical concrete sections, robot parametric steel sections are automatically mapped for correct correspondence section in target program by content generator module. Of course, this process is automatic and not visible for the user. If the section is an arbitrary section with section shape or type not recognized by the content generator, such section can be mapped by name. It means sections of the same name should be created in both programs, and then matching is done automatically by its name. So, in fact, section shape may be irrelevant in such situation, as shown on this slide. If the name is not recognized, mapping dialog window is opened, and it is possible to assign section to not match section by name by selecting any available section on the list and in the databases. In addition to previous slides, to have full user access to Content Generator, it is required to install it together with other Revit extensions. It is available in Autodesk account. At the bottom of this slide, you will find the link to the complete knowledge base article, How to Find the Revit Extensions. As analytical modeling is straightforward in Robot, so here we can present some hints for modeling in Revit under these links. There are an official white paper, article presented at the Autodesk University, and some example YouTube videos in here. We will not focus on them because everybody can easily access them. There are some analytical model settings in structural settings for automatic adjustment of analytical model. As you may see, there are some tolerance values, distances between objects, to be merged locally or located correctly in automatic way. Revit analytical model can be checked by consistency check. Button is located on Analyze tab. Report of this check is displayed automatically right after the check or at any time from Manage tab and the Warnings button. Here is a description of a recommended round-trip workflow. To keep coherence of the model, the changes to it should be made in one program in one time. So, for example, if it's required to make any changes in Revit model, which is already updated in Robot, it's needed to update Revit model prior to applying changes in it. Similar situation in opposite direction. Some hints for workflow. Load case analysis types are preserved in Revit. All types set in Robot will be kept invisible for user. The same for combinations and code combinations. It is recommended to transfer always full model. Split or divided objects in Robot do not update original Revit model. Claddings or curtain walls are not transferred between programs. Arc walls are not important from Robot to Revit. Revit arc walls geometry are not updated from Robot. Columns walls in Revit should be created from level to level, from slab level to slab level. Beams in Revit as a default are pinned. Thus, they are imported to Robot with pinned releases. Stories should be created in Robot before exporting model to Revit. Revit model can be updated also with the design in Robot rebars for RC columns, beams, and RC footings elements. Example video available under the link on this slide. Panels, walls, slab provided, real reinforcement calculated in Robot is not transferred to Revit. Size of concrete RC footings in Revit is not updated after importing design RC footing from Robot. Let's look at the example how to update Revit model. So as you may see, where we have a robot model with results calculated. So just for viewing purposes, I will display MY diagram for bars like that. And this model later on we will import to Revit model, correspondent Revit model. So as you may see, on the integration dialog window, I have selected Update Model with Results. On this window, you may see that the program creates kind of the packages of the results. So on the top part of this window, there is a package name and package set for the finite element results. At the bottom, if in case of having required reinforcement results, there will be additional package for reinforcement results created. In this case, we have just only one package for finite element calculations. So after pressing, program imports and updates the model with results. So we can manage results by the button called Results Manager, and after opening the window we will see the list of packages. After pressing Explore button on this window or Results Explorer button on the ribbon, we can enter the window on which we can select properties results to be displayed on the Revit analytical model. So on top we can see packages if we have more than one, load cases, filtering without load cases, and then in the tree structure of results we can select different results to be displayed. So now you can see MY diagram on our structure. We can switch to different load case. So the same diagram for load case number 1. Also additionally we can display deformation. And also there is a feature not available in robot, displacement, so the kind of the deformation only in one direction. So we can see the diagram of deformation in one selected direction. For slabs, floors, walls, we can display maps, results, maps. So let's go back to robot and now calculate provided reinforcement. First of all, we will calculate provided reinforcement for all beams and columns. So as you may see in the required reinforcement table, all results are available. And then just for demo purposes, we will calculate a reinforcement for just only one slab. So after calculations we can see the map of the reinforcement, and then once again going to link, we will select updating with results, and now as you may see, additional package for required reinforcement is activated, so program will import this calculated reinforcement from robot. So as usual, we will go to Results Manager, and as you can see, there are two additional packages imported from robot. So second run of calculation of results finite element results, and additionally the package the set of results for required reinforcement. So I will select required reinforcement package now and then explore these results. And as you may see on this Results Explorer window, now the tree of results is different because we selected different type of package results, so it's only for required reinforcement. So after expanding the trees, we can see what we can present. So top and bottom maps for slab reinforcement, wall reinforcement. Of course, just only results are presented for the only slab we calculated in robot, and required reinforcement, top required reinforcement result for beams and columns can be presented as diagrams. Now a few slides with typical Revit analytical model errors. Paying less attention to analytical model and model accuracy may result in situations like this. Beams, bars, columns not connected to each other. Similar things happens with walls. Accuracy. Revit walls in robot, as you may see. Walls and slab analytical edges are not lying in the correct planes, so they are crossing other walls rather than meet them in proper plane. Overlapping analytical slabs edges seen in robot. For now, for robot user, it's quite easy to correct model. Sometimes it's time consuming, but there are many tools in robot to do so. But in Revit, looks like a few examples how to correct a Revit analytical model. First, let's look at the correct walls and columns. As mentioned before, under the structural settings, there are analytical model settings with these tolerances, and these tolerance sizes are understood as a distance between objects, analytical points or lines, to merge them into one, to correctly link between objects. So in our case, I will change these values to the smaller one to disjoin this model, which is in the background. But of course, this automatic way may not always work. That's why I want to show you typical ways of correcting model. So as you may see, these columns are not properly connected. So to do so, we have to click after activating analytical model, adjusting of analytical model. So as there are not many tools in Revit to do so, the most precise and the recommended way is to use align option. So after selecting align, we can click on analytical nodes to merge them, to reposition them. So as you may see, the top nodes of these two columns are already corrected. But now we need to correct bottom nodes. So on a plane view, we can also use once again the align function, but align this bottom node to the grid line. And in 3D, we can see the column is disjoint, so I will disjoin it by align method. And now, as you can see, this column became vertical one. Correcting of walls. As you may see, this wall is too short. I mean, analytical representation of this wall is too short. How to correct it? As you may see on the screen, the analytical nodes of the walls are usually presented in the gray color. It means it's not possible to easily move them, relocate them, or use align option on these particular corners or nodes. So for correcting walls, we either have to use wall adjustment function shown as on the button on the analytical object model, or we have to use different kind of the projections to properly move the edges of the wall or planes of the analytical wall. So, because as you may see, align does not work here, so after selecting analytical wall, we have to go to the properties window, Revit properties window, and in analytical alignment section, turn off auto detect for different kind of adjustments, and then select, for example, projection, and select correct level or reference plane, and the model and the wall will be properly adjusted. So now you can see the simple model with slab and opening. How to manage that? From the 3D representation of this model, everything seems to be fine. So editing the boundary of the slab also allows us to change the slab opening geometry. And the opening geometry, real opening geometry, also forces program to change the analytical model opening geometry. So after switching off model displays and turning on analytical model display, we can see the view of our analytical model. So as you may see, the opening is adjusted to the boundary lines created by real slab floor object. But of course, there are some errors made on this model on purpose of our demo. So for example, the slab is analytical lines, analytical edges of slabs are out of the correct lines or faces in Revit. So to adjust it, we have to highlight or select analytical model and go to adjust. And as usual, we will use align option just to align edges to lines, grid lines, or to other reference planes. Here is the way of correcting position of analytical nodes. Analytical nodes are presented as black dots. If they are not moved, so the position of them is automatic position, the dots are much bigger than after moving or adjusting the position manually. So adjusting the position of nodes can be done as previously shown by align method, or by clicking on the dot we can drag it. If the click is made exactly on the dot, we can see the free drag. But there is also the presentation of two short arrows like coordinate system. So after selecting or clicking on one of these arrows, program forces us or allows us just to make move of such dot or such object only in the direction shown by the axis we clicked on. So as you may see, I'm playing with analytical model. It's still not correct. But now, as you may see in 3D, the 3D geometry is still unchanged. So correcting this node by dragging much faster. And how to play with the openings. As you may see also on this screen now, the corners of this of the openings are presented in gray dots. So it's very similar situation to the walls representations. So we cannot drag or we cannot move these dots, analytical nodes. So the only way we can do anything in analytical model of the opening while adjusting analytical model is to turn it off or on. I mean, disable or enable opening from the model. So as shown previously, the geometry of the opening is taken into account from the boundary conditions, boundary lines of the real slab geometry, but disabling or enabling can be activated in analytical adjust. So as you may see now, the opening is disabled in analytical mode, but we can still see it in the real model. So once again, adjustment of the boundaries, boundary lines or boundary points of the slabs. So as mentioned before, clicking on the node, analytical node, black dot, freely move it. The same for midpoint of every edge. And now clicking on the one direction axis, so in this case it's kind of the perpendicular axis to this indicated edge, allows us just to move along this direction, selected direction. So now I will click on the second direction and it just only allows me to move the whole edge in this direction. There is another example with the structure, bar structure, this small tower. From 3D geometry point of view, it looks nice. As you may see on this view, almost perfectly as robot can present it. But in details, the analytical model, so turning off real model and turning on analytical model, in details, as you may see, the model is imprecise. So as you may see, the rafters, roof rafters are above the roof slope. Also, the bottom chord of these trusses are not properly located over the elements, over the columns. Not everything is located in one plane. And also later on you may see that the bracings are not located properly. So to correct it, first of all, we can use the consistency check to see not all but many errors if they are in the Revit model. If possible, after clicking on each item in this window, the program should highlight or display it in different color elements with the problems. It's not seen for now, but some of these nodes should be highlighted into light gray color. But we can see now this model. So I will show you how to correct first the roof of this tower. So on the elevation view, I will turn on display of analytical model. So the green analytical line of top chord will be my reference, let's say reference plane, and I will adjust the beams location to this plane. But of course, it's needed to create this plane. So I will create the reference plane by selecting this object and extend it a little for selecting it easy later. And what's important to, after creating of reference planes, it's good habit to name it, especially if you want to use it in different kind of the selections for projections, because the selection projections are based on the names of the axis, grid lines, and also on names of reference planes. So it's important, if you want to use it for projections, to name such reference planes. So the name will be slope 1, and then after selecting analytical beams on this slope, and then going to the properties window, we can start to use the alignment, analytical alignment part of this window, and switch off or change automatic detection of the planes into manual projections. So as you may see, I'm starting changing the location of this projection onto the reference plane I created of the name slope 1. And now, as you may see, the beams locations are adjusted. Another typical way of correcting under beams by aligning nodes. But of course, it's only possible to align nodes or anything in Revit one by one, so it's hard to make multiple corrections in one run. Afterwards, after correcting the model and also creating the second slope, and you may see now that the roof part seems to be made correctly from the analytical point of view. And as you may see with this big zoom, the analytical representation of some bracing in the wall, let's say wall planes, is not accurate enough, so the bars are not meeting it. So as usual, we can use align option just to merge them. Analytical model also can be corrected after importing in Robot. It's much easier sometimes, especially for experienced robot user. In order to correct the model having some issues with inaccuracies, we recommend to run first detailed correct option, selecting structure axis. So selecting the structural axis option on the detailed correction window. If it's needed, it's also recommended to add some structural axis in Robot to make this process as much as possible automatic. In other cases, detailed correction options can be run with different settings and different parameters, like correcting to plane, correcting to line, or correcting to nodes or points. One can also use different techniques of correcting or modeling in Robot described in webinars 6, 1, and 2. So there were webinars about panel meshing, and different tips and tricks in Robot. Also, there are lots of macros for correcting axes, for example, panel coordinates, rounding coordinates, weeding panels. These macros are available on our forum under this link. some model errors reported by program, especially robot. Geometrical analytical model errors can be reported by consistency check in Revit, and also by verification in robot, such as instabilities or overlapping objects warnings. Other unexpected behavior or errors can be caused by linear non-hosted Revit loads, a very long time of model generation, or linear load has not been applied to the panel warning. First of them is caused by a huge number of non-hosted linear line loads defined in Revit model. The second is caused by imprecise definition of line load geometry. In both cases, the solution is to use the macro in robot to convert linear loads to point onto linear loads on edges, and correct coordinates of lines to which the loads are applied in case of the second issue. Macro doing that available on the forum under this link. Modeling hints can be found on slide 21, but here a few words about curved elements. Revit models' curved beams are presented as true arcs. However, like most structural analysis software, robot structural analysis requires arcs to be discretized into linear segments. In Revit, there are two options to consider it when transferring curved beams to robot. First approach is to leave the analytical beam with its default two-arc geometry. The Revit robot link will automatically discretize the arc into linear segments that are approximately 1 foot in length. For the better outcome, select an approximate curve parameter of analytical beam and indicate the level of discretization. For those who want to export link models with user rebars, please follow the step-by-step procedure shown on this video. So, thank you for attending this webinar, and feel free to ask the questions related to this topic on our question panel.
Thank you, Rafał, for the presentation. I think it covered a lot of very useful information. There's actually one question about display of loads in Revit. The question is, can different load cases be shown separately in Revit model?
Yes, it is such options, not that easy like in robot, but in Revit you have to build a filter to display loads filtered to certain load case.
And there was also the question about the possibility of changing of the boundary of analytical model of the opening, which I believe has been shown. But can we see that again?
Yes. So let's switch to this video. The boundary, the opening geometry can be only adjusted by modification of the slab boundary elements. So, oops, I'm very sorry, once again. So, of course, this approach is correct in case of creating the boundary through the boundary lines, by the boundary lines. So, in case of creating the whole geometry with the boundary lines, or one is able to change the opening geometry by moving or adjusting the boundary geometry. But in case of creating openings by shafts, and the same as concerns the wall openings. So they are created by shafts. The shaft geometry should be changed in case of considering this change in Revit model geometry, real geometry of the slabs, and also the analytical slab geometry of the opening.
So there is another question, that whether a robot is able to handle continuous beams and cantilevers, and if there is any special modeling technique required in Revit.
No, in model either you can define beams from let's say column to column, or as a one continuous beam. So it's irrelevant for transfer. So up to you.
And there are two questions for robot actually. One about instabilities, different three types. So basically, there are no easy way to tell what they are caused by. The first two types are usually lack of support or the mechanism, the structure. The third one is the large difference in stiffness of elements of the model. But this is very individual situation, so it's difficult to give the general advice without having a model. So if anybody has got a situation like that, we've got a robot forum, so you may try to look of the existing solutions, or just attach the model so that either we or some other users will have a look at that. And the question about the catalog of the steel sections, I believe that was covered during one of the previous RSA webinars. That's the exactly step-by-step description that you can watch on the available recording, how to create a new database, how to create a steel section, how to calculate properties.
So there is a question about the foundation in Revit, and how should we input the supports to have it in robot, elastic or for foundation. As a default, let's look at the mod. Okay. So. Okay, I will. Okay. So here's the model like that, and this is the representation of analytical supports. And if you click on analytical support, you will see boundary conditions, and you may switch to user, and then select release direction or spring, and type the spring modulus values here, and it should be considered while exporting. So either you can create your own support with fixed or released directions, or spring support, and it will be considered during transfer. As a default, if you apply to the model, let's look at the 3D view. Okay. So I will turn off whole analytical model now. So if we apply let's say, standard isolated footing. In such way, the footing, even without assigning this analytical support, such footing has also analytical foundation representation, and you may find it here, and as a default it's considered as a fully fixed support. So either playing with analytical support, you can select different degrees of freedom to be free or fixed, and also add or elastic coefficients, or in case of using standard objects, 3D objects, 3D model objects, you may see the settings of them on the properties window as a default fixed. There is a question about adjusting analytical model of the sloped slab, but to the slope not parallel to this slab. I have never tried it, but I guess it is possible. But as shown on this example with this tower correction, you have to create a reference plane and make projection to this reference plane. So this reference plane can be created, let's say, above or below the correct slab slope, and it should work. But for now I'm not sure because I haven't tried it, but I guess it should work in this way. So there is another question about the React structure and the link to the Revit. For now, what we can say that of course the link will be implemented, but we are not allowed to tell you the time of the implementation. So either it will be in next technical preview or in 2 technical previews. So for now it's not decided yet, but of course the link will be developed and available in React Structures and Revit. So there is a question about the link. So I will read the whole question because it's long enough. If there are 2 files, Revit and Robot pair of files automatically link. Where is the link between them visible? Are they stayed linked even if you open only one of them, or they have to be both opened? Do the files always remember from which file they have been transferred? So you can save, for example, Revit file on another location with another name, and you transfer it already into Robot. So the transfer is kept in the meaning of the direct transfer, because if you use the transfer by the file, it doesn't matter. It doesn't matter whether it's exactly 100% pair of the files. But in case of direct import or direct export, direct integration, the both files must be opened simultaneously in both programs at the same time. So for example, if you work in a Revit file and then export model to Robot, and later on save the Revit file under a new name, the link will not recognize the Robot model as the same model of Revit file. So the updating will not make real update, but it will import the model from Robot, because the link It also recognizes the file names, not only the contents of the file, but also the file name. So in case of direct integration, direct link, both files should be open at the same time simultaneously.
Now there's another question whether it is actually possible to have one file. I mean, like, if you mean one file having both robot and Revit information inside, that's not possible.
The question about creating new rebar shape in robot, as mentioned during the presentation, so here is the link how to modify a rebar database and use it for Revit also. And of course, in case of creating database, there is additional hint, I guess, also on our previous webinar how to create rebar database. If not, the full description how to do it can be found on our forum. So this hint here is just only how to properly connect or link or export or set databases, rebar databases for both programs. But additional hints for creating rebar databases are available either on webinar, on one of the previous webinar, or on our forum.
So if there is no more question, I think we would like to thank you for attending the webinar. And of course, if anybody would like to have additional information, there is a robot forum that I hope you're all familiar with, so you can post any question or issue that you find difficult to solve. Thank you, Rafał, again for your presentation.
Thank you for attending the webinar, and a small advertisement about next session, which will be on the 23rd of March, and it will cover the topic of advanced steel and robot link. Thank you for attending this webinar.